Hello, what's up everyone? Welcome to this series of videos to learn how to develop iOS apps with Swift and Xcode. So this is going to be a beginner's tutorial. So if you want to learn how to create iOS apps but you've never done that in the past and you've never used either Swift or Xcode, you are at the right place. It's been quite some time since I wanted to create this series of videos. If you look on my channel, you will see that I have a lot of content about iOS, but I didn't have this particular piece of content to guide beginners with their first steps in the iOS ecosystem. But what happened is that a few weeks ago, as I'm recording this tutorial, Apple released a series of written tutorials that go over all the steps that you need to learn in order to get started with iOS development. So I figured why not do these tutorials live? This way I can go over them with you, I can add additional explanation. If something is weird or hard to understand, I will unstuck you, and basically if you stick with me, you will do the tutorial and you have the guarantee that you will not be stuck on something that you don't understand. If you want to check the tutorial by yourself, please feel free to do so. You have the link to check it out in the description of the video on YouTube. And by the way, I'm recording this tutorial live, so live on YouTube. So if you're watching live, well, first, thank you for being here, but also don't forget that you have a chat where you can make remarks, ask questions. I will try my best to answer them. And remember also that the questions and the remarks that come to your mind are probably the same than the one that people watching the replay will have. So please voice them. This way, you will also give a voice to people who watch the replay, and I think that's pretty cool. I see a few messages in the chat, but it seems like we have Niles and Elnor. So welcome to the live stream. I see you're talking with each other, so I don't think it's questions addressed to myself. But I'm glad to see that we have people that want to go on this discovery journey, this learning journey. I think I've said more than enough for the intro. It's time to actually get started. So I'm going to go on the tutorial, and I'm just going to go over what we're going to learn. If you look at the tutorial, you will see that it's quite comprehensive. Honestly, the team at Apple that made these did a pretty good job. So today we'll cover this part, so about the Swift UI foundation, so getting familiar with the tools and technology we use to create modern iOS apps. So we will explore Xcode, which is the software that you use in order to develop apps for iOS or for macOS or for any Apple platform. Then we'll learn a few more technicalities, so about views, structures, and properties, the basic building blocks of a Swift and a Swift UI app. Then we'll learn a bit more about UI, about layout and style. So how do you display a UI that is visually pleasing? How do you handle buttons and states? So how do you handle user interaction? How do you handle lists and text fields? And we will stop here for this tutorial. So actually this will take us more than one video. I think this will be at least 2 videos, maybe even 3 videos. And then the next part is about Swift data. But this part, I've actually already covered it. So you can find this part being covered on my channel already. We did that the past 2 weeks. And the next part is about spatial computing. So maybe I will do it after in the future. Maybe once I will have been able to get my hands on the Vision Pro. But it's nice to see that we have also this option to learn about how to develop for Vision OS and the Vision Pro. So let's get back to the topic at hand. Before I start, something I forgot to mention is that I'm recording. We are in April 2024, so it might seem stupid if you're watching the live stream because of course you know when we are, but if you're watching the video in the future, it's always good to know that the tutorial is from April 2024 and from the days of iOS 17. I'm saying it because if you're watching this and it's 3, 4, 5 years from now, maybe the information I'm going to share is a bit old. So keep that in mind if you are watching a few years in the future. But if you're watching this video a few years in the future, it's pretty cool. It means that the video managed to stay alive and stay relevant. So that would be pretty cool, to be honest. So let's get started. So chapter 1, we're going to explore Xcode. We'll get to know Xcode and SwiftUI by creating a prototype of a messaging app. We'll learn about syntax for Swift and how to use the source editor and preview. So let's get started. So first, it seems we have some kind of intro for this series of tutorials. So welcome to Develop in Swift tutorials. So these will teach you how to develop apps using Xcode, Swift, and SwiftUI. This content is for anyone. No prior coding experience is required. What are we going to learn? We'll learn how to use Xcode, Apple's advanced tool for developing apps, the basics of Swift, Apple's modern programming language, which is designed to be easy to learn and fun to use, and a foundation in SwiftUI, which helps you build great-looking apps with the power of Swift. So the most modern technologies that you have for now in the Apple ecosystem. I'm also going to make myself a bit smaller because I take a lot of room and I don't want to hide any of the text by mistake, because the text is way more important. So each chapter introduces a new concept in Swift, or rather new concepts in Swift and SwiftUI through the experience of building a small project in Xcode. It's what I really like when I did the Swift data part of this tutorial, is that it's really like learning by doing, and I think they did a great job at introducing each concept and making you do it, which makes it way easier to understand how it works and to just like get your to wrap your head around how it works. That's the expression the idiom I was looking for. So start with the tutorial where you'll follow step-by-step instructions to create prototypes, app screens, and fully functioning apps. After the tutorial, read a wrap-up article to review what you learn and continue practicing your new skills. So it's really like the structure of like you have one tutorial to learn something and then a wrap-up to recap on what you've learned. And also they give you like if you want to go further, they give you some like challenges that you can do on your own. And I think it's a pretty good value also. If you're an educator, download the educator guide for an overview of the skills and topics introduced in each chapter. So I didn't check this actually, but if you are teaching iOS in a school or in your company or anywhere, and you're using these tutorials as teaching material, as I'm doing it right now, I guess you might want to read this. I didn't check it out because I really wanted to discover the tutorial as I'm teaching it, because since I know Swift and iOS for more than 10 years, I mean, Swift is not yet 10 years old, but iOS is a bit more. So I know iOS for more than 10 years. So it's very hard for me to be like in the beginner state of mind. So I was like, at least I will discover the tutorial live, and it helps me like build a bit of empathy with someone that is discovering Swift and iOS as they watch this video or as they follow the live stream. So what are we going to need? We are going to need curiosity and imagination. All right, I guess we've got that. A Mac running macOS Sonoma or Ventura. So I'm currently running macOS Sonoma, so the latest version of macOS as I'm recording, and Xcode. So you can install Xcode from the Mac App Store, or you can also download it from a website. I mean, you can download it from the developer portal, and you have a website called Xcode Releases with links to download it. I would recommend you download it from the developer portal rather than the App Store, honestly, because it's quite slow to download from the App Store. But if you know nothing about computer science or anything, get it from the App Store. It's easier, and it will look like getting any other kind of... it will be the same process than getting any other app, but people who are a bit more seasoned know that downloading Xcode from the App Store, it can be quite long, and the installation can be very, very, very long. But so, yeah, it might take some time to download and to install. And the install time can be surprisingly long. You don't need an iOS device because Xcode already includes tools that show you how your app will look and work right on your Mac. To be correct, in a real world situation, you want to have an actual iOS device because there can be small but important differences in how an app looks like in the simulator and on a real device. So for a real app, you would always want to test on a real device, but indeed, to follow tutorial, you don't need a real device. Actually, almost all of my videos, I used the simulator, and it's more than enough when you're doing tutorials. A few words of advice, and then I will answer the question I see in the chat. So the only way to learn to develop apps is to make them. It's an art you practice, just like learning to paint or play an instrument. Type the code in your project instead of copying and pasting from the tutorials. You'll build your skills and confidence more quickly. So that's a very good point here. Me, I will be copy and pasting because we want to cover ground, and I don't think it's super interesting if you see me just like typing code all the time. But please, indeed, especially if you're learning, try not to just copy paste, try to write it yourself. It really helps understand what's happening. And with the code completion in Xcode, it doesn't take as long as it seems. And finally, bring your own ideas. The project in each chapter can be a great starting point to build something you care about. So if you have ideas on how to improve and how to go further, please do it. The tutorials, they are a starting point, but they should by no means be a limiting scope. You can always go beyond that scope. And so it's time to get going. We can navigate using the bar, so at the top, use the menu to choose, and we'll do things linearly. So we're going to move on to the next chapter, which is about getting started with Xcode, Swift, and SwiftUI. But first, let me answer the question in the chat. So let me display it on the broadcast. So do you think it's problematic to learn SwiftUI at the same time as Swift? Possibly because it would be hard to differentiate what is SwiftUI specific versus what is part of the core language. That's a good point. I would say you need to start somewhere. And people who watch this kind of tutorial, often what they want is to get a head start and get something working. So if you have time to learn, maybe indeed it can make sense to learn about Swift first, but learning by doing and getting an understanding of what you're doing, I think, is also valuable. But you raise a very good point, is that we're going to see things that are part of SwiftUI and others which are part of Swift. And it can be interesting after the fact to try and understand where the line is and why you have this difference between the two. So one is a language, Swift is a language, and SwiftUI is a framework that uses the Swift language. It might be interesting to make sure that you really understand where is the line between the two of them. That's a very good remark. I will try to point it out when I can, but it might be useful if I don't point it out, that you ask yourself, is this part of SwiftUI? Is this part of Swift? That's a very good remark. And hello, I see a few more people. Hello, Yash. Nice to see you here. I know you've been following the channel since almost the very beginning, and nice of you to drop by. So let's actually get started. Let's discover SwiftUI. So we're going to start our app development journey by getting to know Xcode, Swift, and SwiftUI. And in this first project, called Chat Prototype, we'll code a chat conversation using text views. The text and colors in the project are just suggestions, so feel free to make it your own by changing the words and style. All right. So we're going to create a new project, and we begin by downloading Xcode, the tool you use to create apps. So I've already downloaded it because it's quite long to download, but if you haven't and you're watching the replay, now is your time to download it and pause the video until you've installed it. So Xcode is the software that manages all the files that make up an app, so images, icons, project settings, and code. It's what's called an IDE. So IDE stands for, if I'm correct, Integrated Development Environment, and basically it's the all-in-one software to create apps for the Apple ecosystem. So whether you want to make a Mac app, an iOS app, visionOS app, a watchOS app, any kind of app for the Apple ecosystem, you will need to use Xcode at one point or another. So step 1, downloading Xcode. So I trust you to do it. Step 2, launching Xcode. So, and when you launch it, the first time you open it, you will see this. So what you will want is to download and install the iOS runtime, which is what allows you to run iOS locally on your Mac on what's called the simulator. So you will want to download this extra 7 and a few gigabytes worth of data. And of course, if you want to try these other OSs, you might want to download them. But of course, you can always download them later when you need. So in the welcome window, click Create New Project. So I've done it just before, so I will switch to Xcode on the next step. And what's a project? Because it's a very important word, project, which you will see appear often, and it does have a technical meaning. So a project, it's what contains all of the components of an app. So it's all of the source code that describes how it runs to the icon that represents it. So basically, the project, it's everything you need. It's everything you need to build an app. So all of the sources, so the source code, the images, the sound, maybe the videos, everything you need to build the app, and the way to build it. So the build steps, how do you compile the app, etc. And so this is managed in a project file. And so when you hear the word project, this is what it means. There is a very technical sense to project that you might not be familiar with if you're just getting started with iOS development. So next, you will want to choose which template to use. So Xcode has a variety of templates that basically each contains some boilerplate code to create a certain kind of app. I use the word boilerplate. If you are new to computer science, you might not know what it means. Boilerplate, it means the kind of code that you need to write in order to just get started. So for instance, if you do an hello world, maybe you need to import the function that allows you to print to the console. That's the kind of thing. If you want to do a basic SwiftUI app, you need to have code that imports SwiftUI, that displays a basic view, and that displays some text on the screen. That's also what we call boilerplate. So that's a term that you might see often when you learn about how to create apps. And so here you want to use a template that is in the iOS section, and the app template, which is the most basic one and the one that you almost always end up using. I mean, in my experience, I almost always use this one. I don't remember when I actually used the document app, for instance. I guess it's much rarer that you use the other one. So you will choose this one, and then you will be on step 5, which is the one where I'm at currently in Xcode. I see a very good question. So somewhat unrelated question. Does Docsy have support for making this new style of tutorial docs like this? I know you can make tutorials, but think that some styling things may have changed. I think it might be what I think Docsy might be able to do that. Maybe not all of it, but a good part of it, because if you remember, I think it was in either at the end of last year or the beginning of this year, but I followed the tutorial about TCA, the composable architecture, and it really looked like this one. And I think, I mean, if the guys from TCA, which are not part of Apple, have made it, they use Docsy to make it. So honestly, I think it's possible, and I would recommend that you check out what the people at Point Free that make TCA have used. Maybe even ask them on social media. But I think this can be generated using Docsy. But I haven't done it myself, so I can say for sure if you can do all of it using Docsy. And if you don't know what Docsy is, it's a tool that Apple released last year, so in 2023, that allows you to write documentation in a markdown syntax, and then have the tool, so this Docsy tool, generate these beautiful web pages for you. So I think Docsy stands for Documentation Compiler or something like this. So that was a good point. Thank you for mentioning it. Let's go back to the tutorial, and so we will call the project Chat Prototype. So as you see, I'm doing copy paste, but you might not want to follow my example on this one. So I've selected the app template. So I call it Chat Prototype, and you can see here they explain what the other options are for. So next to organization identifier, you need to enter name.yourname. So for instance, if your name is Sophie Sun, you will enter name.sophiesun. The organization identifier is used when you upload an app to the App Store. And the App Store requires your organization name to be unique. You typically format it as a reverse domain name like com.apple.com. So me, I did com.vincentpradey, which is my name. But Apple suggests I should have done it something like this. And the goal is that if I ever were to upload this app to the App Store, this would need to be unique across all apps, because this is what uniquely identifies my app. Actually, if I'm correct, I think there is something that is appended before that identifies my developer account, and so I think this name only needs to be unique among my apps. Like all of my apps will need to have a unique name, but not all apps in the world need to have a unique name here, but I'm not 100% sure, to be honest. So it's called the chat prototype. So I've put my organization identifier, and you can see that it gives me the bundle identifier, which is just organization identifier concatenated with the product name. And this is what iOS uses to uniquely identify an app with maybe an extra info added in front to identify the developer account. And this is very useful. For instance, when an app receives a push notification, what happens is that the push notification is sent to the iOS device and it contains the name of the app. And this is what iOS uses to know which app is the notification for, because otherwise, Xcode iOS needs to have a way to know this notification is for this application, and so this is how it's done. So you can see it's kind of like the phone number in a way, but the phone number but for an application. It's kind of the same concept when you think about it. And then for this tutorial, you don't want to change the settings, so I will put them back as they are by default. So interface Swift UI, language Swift, and storage none. So I had the first two correct. Storage was set to Swift data because, as I've told you, I followed the Swift data tutorial the weeks before, but I will put it back to none. And they've left include test checked, so I will do the same. And so next I click next. Sorry, you cannot see it. Let me move it. Okay, this way you can see it now. So I'm going to click next here, and let's see where it gets me. So where do I want to store the project? So I'm going to store it on my desktop. So you can put it, of course, wherever you want. They ask you to uncheck the box to create a Git repository on your Mac. I'm not sure the reason why they ask you to do that, but maybe they will talk about Git later. Maybe they want to take this part out of it. But just if you don't know about what Git is what's called a source management control system, if I'm correct. I don't know what the actual acronym is for it, but I know that there is one. But since Git is so popular as a way to handle changes in your source code, I think I always use Git, so I don't remember the name of the category of software that Git is part of. But the job of Git is to be able to track, yes, VCS, version control system. Yes, I remembered, I think CVS, no, maybe CVS. There is one that is like that was one of the first software to do that. So I think it's Control Version System, CVS. I think it's also the name of a pharmacy chain in the US, but that's just a coincidence, I think. But yeah, this software. So there is Git. An older one is also SVN. There is also Mercurial that you might hear of. Their goal is to enable you to track changes in your source code by being able to commit incremental changes into your source code and being able to go back to previous stages of your source code if you've made a mistake, or create what's called a branch in order to work on several features in parallel. So I'm not going to cover this unless the tutorial does it, but if you're new to developing apps, you might want to take the time to learn also how Git works, because Git is a very important part of the workflow of a software engineer. So it's nice that I have the opportunity to mention it here. But let's uncheck it so that we do the same thing than them. And finally, you do create to create and save the project. So what I've just done. Next, we're going to explore the project to see what is inside an Xcode project. And so we'll be exploring the key features of Xcode, the navigator, so to move about inside our project, the editor to update, to make changes to the source files, and the preview to see what our app looks like. So step one, it's about what is the navigator. So the navigator is the leftmost column in the Xcode window, so the one you can see here, the part that doesn't have this white veil over it. So the project navigator is selected, so it's the first tab right here. You can see its icon, a small folder highlighted at the top of the pane. The project navigator displays all the files in your project. Note that content view is the highlighted file. So you can see it's here. So on the left, we have the navigator. We have several panels here, and the first one that's selected is the one that's called, I think they said it's called the project navigator. And this allows us to navigate through all of the files inside our Xcode project. So we'll go over these files one by one to see what they have inside, I guess. And you can see that the current highlighted file is the content view, whose content is displayed in the editor, which is right here. And I guess we're going to talk about just after. So indeed, next is the editor. So it's where you write your source code, and it's displaying the code from the content view file because it's the one that is selected in the navigator. When you select an item in the project navigator, its content appears in the editor. So very basic, but also something that might not be that intuitive if you're getting started with developing apps and doing computer engineering. The preview, so the part on the right here, the preview canvas is the right part of the editor. It shows you what your app would look like running on a real device. And you can control preview options like device size and light or dark mode using the buttons along the bottom. So a preview only appears, of course, when you are editing a SwiftUI file. Actually, you can see the preview is defined in code right here. I guess we'll go over about what this syntax means just after. And as they said, you can override if you want the color scheme, so to switch between light and dark appearance, or to switch between orientation, or to switch between dynamic type, which is the size of the font. You can see I made the size of the font larger, and now I'm making it get back to its default size, and I'm also going to uncheck overriding the color scheme. And if I make a change in the code, so if I put, for instance, capital W here, you can see the preview is reflecting these changes in real time. But I guess I'm getting ahead of the next steps. So let's see. Now it's about exploring our code. So we're going to read through the code. Swift and SwiftUI are designed to read like natural language. Swift is the programming language you use to write your app's code. SwiftUI is a framework that provides views, controls, and layout structures for creating your app's user interface. And as the name suggests, SwiftUI is built using Swift, and it leverages several key features of Swift in order to have its very powerful and I'm trying to phrase this correctly, but let me rephrase it. SwiftUI is built in a way that you don't need to write a lot of code to get the result you want. And this is possible because SwiftUI leverages a lot of features of Swift, and actually several features of Swift were developed in part or in total because Apple had the idea of building the SwiftUI framework. So we'll see that the name of many Swift elements are common English words. So for instance, image, image scale, text. And they all hint at how they create the interface. And they highlight something is that image scale is formatted using what is called camel case. So the words are glued together without spaces, and each word after the first one is capitalized. So this is something important, and this is something that is very, very typical of computer code, is that this is what's called an identifier in the terminology of programming language. And identifiers, most of the time, they don't have spaces in between them, because a space, it's actually hard to explain simply the reason for it. But basically, when you have a space in most programming languages, it means that you're talking about two separate concepts. And so if you were to have a space here, then image and scale would be two different things, because typically you would use a space, for instance, when doing 3 plus 3. And so you separate different elements. Here it's not the case. You have two words, but they are still part of the same concept. And so these two words are grouped together in this thing that's called an identifier. Here is the name of a method that we are calling on the image. And so we use this syntax called camel case in order to put several words, to glue several words together, but still keep a good readability. Because if we didn't have the first letter of all the subsequent words being uppercase. You can see here it's hard to read like image scale, but it's hard to read it at a glance. Same thing here, like foreground style, it's a bit easier, but it's less confusing than for this first one. But you see, like the first one, like is it images calé? Is it image scale? Is it imag scale? It's not clear. Whereas when you do this, it makes it much clearer. You might see other programming languages that use sometimes like underscores as a way to separate words without using a space. Swift chose to use camel case, and it seems to be one of the most popular choices in many programming languages. But you can find the two approaches, to be honest. Some languages use camel case, others use these underscores, which we call snake case, because it kind of looks like a snake if you think a lot about it. So it's kind of like, you know, like when they tell you that the stars, they are in that shape or this other shape, you need to think about it. You need to squint a bit at it to see that it's a snake case. But the idea is that it's kind of like a snake, you know, like being like having its body like being like this. So you need to use your imagination. They told us at the beginning we would need to use our imagination, but that's the name of it. And camel case is because it's similar to how a camel looks like with the bumps on its back. All right. And yeah, using snake case. Oh yes, true. Kebab case also exists with a dash to separate the items. Kebab case is a bit more rare these days, to be honest. I think one of the places where I would expect this, so kebab case is in XML files, but XML files are less and less popular, which is arguably a good thing. But you're absolutely right. This one does exist. And good to know that some people use it for unit test function names. Personally, I would rather go with underscores, but I think it's maybe more like force of habits. But yeah, kebab case. It's been a long time since I've used this one. To be honest. All right, let's go back to the tutorial. So then they tell us to look for the braces and parentheses in the code. We can see that these characters are present a lot. And so parentheses, they usually have information related to the code immediately before them. Braces, they are like containers. They usually group multiple lines of code into one chunk. And the word that we use to describe this chunk is often a scope. So the curly braces, they define a scope of code. Whereas, so for instance, here we have a scope of code. So this is the code that is inside the property called body. And we'll learn about what is a property just after, I guess. And parentheses, indeed, often they are attached to what is immediately before them. So for instance, here, these parentheses, they allow us to pass the arguments of the image. So here it's the name of the image, the name of the system image, so the built-in image as part of iOS. And here for image scale, it's the argument we pass. So what is the actual scale of the image? We used a large image, but we could also have said a medium image or a small image. And you can see the size has changed every time I updated the value of the argument. And I think like, yeah, these parentheses and curly braces, they're really like, when you look at this, it's what's typical of showing code. Like if a movie wants to show something that looks like code, they will put something with lots of curly braces and parentheses and a lot of syntax coloring. And basically, to someone who doesn't know anything more, like this looks like some hacky computer science thing. So this is very typical of source code. And especially source code of languages that have like inherited from the C programming language, which is a very popular language that started, I think, this whole pattern of using a lot of curly braces to define scopes of code. And you can, if you double click on them, you can open or close them. So let's see. actually, so when you double click, you select everything inside, and you have a feature in Xcode to be able to close them, but I might have disabled it. It's in text editing, it's this thing, so like the code folding ribbon, they might be referring to this, might be referring to that. I've disabled it because I don't use it that much, to be honest, and also because when I do screenshots for my website, I think that it's cleaner if you don't have this folding ribbon, but indeed you can close. Oh, I think no, they meant try double clicking on it, and so to show you that you can just select everything that's inside of it. It's a shortcut, and also if you go over a closing brace or parenthesis, you can see that the corresponding opening one is being highlighted. Sadly, it doesn't work. So actually, it works. So yeah, it works for the opening curly brace. Also, you can see it. It doesn't seem to work for the parenthesis for some reason. Actually, so that's weird. Like here it works for the opening one, but not here. So it might be a small bug in Xcode. When you work on iOS apps, you will come to learn that Xcode can have small or large bugs at times. So it might be a bug of Xcode here, but when you move your cursor over a parenthesis or a curly brace, it will show you what is the corresponding opening or closing parentheses or curly brace. And that's very useful when you are navigating large pieces of code and you're a bit lost and you want to know where is the other part, or you can just double click and you can see the whole content being selected. Now let's look at the indentation of our code. So indentation are the leading empty spaces before you have actual characters on a line. So you use indentation to reflect the code's organization and make it more readable. However, code without any indentation will still run. So if I take this code, you can see that it's indented. So basically, every time that you are nesting child content inside a parent content, so basically every time that you meet an opening curly brace, you add one level of indentation, which usually is 4 empty spaces. And you can see that when I hit enter, Xcode is doing it automatically for me. And this makes the code easier to read because you have this visual aid to understand the level of nesting of your views. And so it becomes clear that the VStack here is inside the body, that both the image and the text are inside the VStack, etc., etc. However, this is not mandatory to make the code build. So you could imagine not doing a correct indentation, but you will see that as soon as you do it, the code becomes much harder to read. Like this is much harder to understand what's happening at a glance. Like you see this, okay, what is it part of? You need to move. Okay, it seems to be part of this VStack, but imagine on a more complex piece of code, it would be very hard. Compare it to what we had before, which I can put back by doing Control plus I. This is much better. So indentation is very important, and you should always like strive to maintain a good indentation. And it's very easy. Just select the code, do Control plus I, and it will be done automatically for you by Xcode. So really, my point here is that there is no excuse to not have a good indentation, because it helps tremendously to understand how the code works and is structured, and it's basically free. Xcode does everything it can to help you have a correct indentation. Now, let's talk about syntax highlighting and syntax coloring. So you've probably noticed that Xcode colors different parts of our code according to their purpose. This is called syntax highlighting. You can often see the terms also of syntax coloring, but I think Apple prefers syntax highlighting. So some things, or rather some words, such as struct here, are keywords in Swift. So it's reserved words that have a specific meaning in the Swift programming language, while others, such as image, are features of SwiftUI. And that's why they are colored in different colors. And you can turn off syntax highlighting or select a different color scheme by choosing an option under Editor Syntax Coloring. So where is this syntax coloring? I know you have it in the theme here. So for instance, you can change the theme and you can see that it can look very different differently. So me, I use presentation dark, and you can see that indeed the color is not the same, and even the formatting, this is bold, is not the same for keywords than for comments, than for instance, declarations which are at the level of the project or at the level of something that's being imported. So this is super useful. I didn't know that you can select like your cursor. You can put an underline cursor if you want. You can put like an underline cursor like this. I didn't know you could do that in Xcode. And you can also put a block cursor if you want. So you learn something new every day, I guess. I still recommend you keep this one because it's the one we are most used to. And so can you deactivate? You can deactivate. Maybe is it here? I'm looking to find how to deactivate this. Okay, this is where you select for the indentation. Where do you disable this syntax coloring? Because it would be funny to see the code without any of it. I don't really see it. Oh, maybe actually, no, they said I was looking in the preferences, but it's in editor. So no, editor is in the menu. So editor, it's in one of the menus. Like I'm sorry, I think it's outside of what's being streamed. But editor, it's actually I shouldn't say sorry. I should move the camera because what's important is that you can see what's happening. So editor is right here, and so where is this syntax? Oh, yes, syntax coloring. So if I do none, wow, you can see this is much harder to understand at a glance what's happening. I wouldn't want to have to work with this kind of code. So imagine if you have no syntax coloring and no indentation, it's going to take you a lot more time to write your apps. So of course, don't do this. Put it back to default for file type, and this is much better. I think we can all agree. On this. All right, and then next step. Find the text hello world in the code. So right here, it's colored red and surrounded by quotation marks. Swift calls a written language like this string. So string stands for string of characters. So a collection, an ordered collection of characters. And whenever you are handling text, it's going to be done through a string. And so strings are defined by putting quotation marks, double quotation marks at the beginning and at the end of the string. Okay, now we're going to edit code and make mistakes. So we're going to change the code in the editor and see how the preview updates in response. Xcode has features common to other text editors like copy and paste, undo and redo, and text selection. So I'm going to hide this because I'm going to show it to you in Xcode directly. So step one, we change the text inside the quotation marks to a word or phrase of your choice. Make sure not to delete the quotation marks themselves. Note, you won't see the preview until Xcode finishes downloading the iOS platform. So if you are just downloading and launching Xcode for the first time, you won't see the preview until you've installed the iOS platform, because remember, you need to download it separately after having installed Xcode. So let's change hello world to a hello YouTube, for instance. And you can see, let me make it a bit bigger, that the preview does show hello YouTube. So the preview is reflecting in real time what's the content of my content view. Now we're going to make a deliberate mistake. We'll delete the string inside the text, including the quotation marks. And we'll notice the error banner in Xcode that popped up on the line of code we edited. When Xcode can't understand what you wrote in the editor, you'll see messages like this. So I'm double-clicking the quotation marks to select everything, so it works just the same way than when you double-click on a parenthesis or on a curly brace, and I remove everything. And so now you can see we have a failure, and the failure says, let me hide the left panel, missing arguments for parameter verbatim in call. Insert verbatim and then a string. So let's see what the tutorial also tells us. So now start to correct the error by typing one quotation mark inside the parentheses. So we are putting back the string argument that we passed to create the text. The editor may automatically insert a second one for you. If so, delete the second one. So you can see it didn't. So we can see the rest of the code on this line is colored in red. And so here they want to show us that sometimes you can cause temporary errors by putting the code into an invalid state as your type. The current error is a good example. Text needs you to supply a string for it to display, but you haven't finished typing a string. So you don't have a correct string right now for now. So they suggest that we click the red icon at the head of the error banner to expand details for both errors. And it says the new error is unterminated string literal. So let's see. Indeed, unterminated string literal. So we began to start a string, but you need to finish it with another double quotation mark, which I haven't provided yet. And a string literal is the kind of Swift string you've been working with, text inside quotation mark. So literal, this word can be a bit weird, but basically this right here is a string literal right here. If I write this is an integer literal. So literal, it just means that the value is written in the source code. That's what literal means. So you can kind of understand as like, you can kind of understand literal as being something that's literally written inside the source code. So this is a literal string. The reason why there is this difference between a literal string and actual string is because there are advanced operations that allow you to take the literal string and turn it into a more complex object. By default, a literal string is turned into a string, but if you want, you can turn it into an object with more features. For instance, you could imagine turning this into a URL if your string contains a URL, but by default, literal strings are turned into strings. But in the eyes of Swift, the two things, literal strings and strings, are still slightly different because of this mapping that is done when you build your project. This was a high-level explanation of something that is like actually quite complex and quite subtle. So if you want to learn more about it, I really encourage you that you search more about what a literal string is in Swift and how it works, but it's an advanced topic, so I won't cover it in this live, which is supposed to be a beginner tutorial. And so they tell us that all languages have rules, including Swift. If you begin a string with a quotation mark but don't close it with a second one, you've broken a rule about string literals, and these rules are what's called the syntax of the language. Notice the closing parenthesis is now red, because Xcode's best guess is that the closing parenthesis is part of the string. And indeed, maybe you want to keep writing something and finally close the string. All right. Now let's get back to how it was. It was like this. Okay, it was like that. So we're going to add a second quotation mark to fix the error. So like that. Now the code is correct because we pass in an empty string, so a string that contains 0 characters, and this is valid. Just like you can have an empty array, just like you can have an empty set in mathematics. Just like 0 is a valid number, you can have an empty string that contains no character. And so the preview on the right now has no visible text, just a glob image. That's because the text is an empty string, so there is no text to display. But we are back to having valid source code. This is something that builds and that can be run on an iOS device. And step 6, put your greeting back in the text view before you continue to the next section. Your code is working again and you've completed the first part of your conversation. All right, so I'm going to put back hello YouTube like this. All right. I see a question about what do you think of beginning an iOS dev career in 2024. It's a topic that would be worth being discussed at length. I won't do it because it's a bit outside of the topic of the live stream. But honestly, I mean, I don't monitor the job market closely because I already have a job and I'm not looking for a new one. I would say if you're committed to being like above average and quite good, so to really understand things at a deep level, I would say that there is still room for talented people. It might be either junior positions or positions for simple projects that might be a little bit harder to get a job at. Either because the job market has become tougher, people can rely on AI tools more to write simple code where they don't really care about it being correct or it being maintainable. So I would say if you want to get into iOS, probably think about do you see yourself doing this and keep learning continuously over the next 2, 3, 4 years in order to keep improving your skills and reach a very good level. I think in general that this is the recipe to get a good amount of success in a career, but also with more junior positions becoming more and more scarce, this might be like other approaches where someone would only learn the basics and be happy with that might become less and less successful, or way less successful than they could have been a few years back when there was a very high demand for all kind of software engineers. But it's only my take. Don't take it like as gospel. I don't follow the job market very closely, as I was saying. So ask around, ask opinions for other people, ask opinions of people that are working in the job market that you are looking to apply to. For instance, I work in France. If you're planning to apply, I don't know, in the US or in another country, ask people who work there. They will also have not a better, but maybe a more informed opinion to share that I cannot have because I don't know every job market. So that's the best I could give as an answer without going too much off track. But thank you for asking this question, because I think a lot of people that are watching such a beginner tutorial might ask themselves the same question. All right, section 5, use the library to add a text view. In SwiftUI, a view is part of the interface of an app. Text is one example of a view. Views are distinct from the data they display. Text is the view, and the string inside the parentheses is the data. A very important distinction to have in mind between what we often call the UI, so the view, what displays the data, and what we often call the model, so the data that is being displayed. And being able to efficiently separate the two of them is actually a key skill at computer engineering. So step 1, we're going to delete the line of code beginning with image and the 2 lines below, and then add a new line below the text view. So this, off you go, and we add a new line below the text, which is a view, such as VStack, but I guess we'll go into what VStack is a little bit later. Just saying it in case you wonder, VStack is a way to combine several views vertically. You can see we had 2 views, so image and text, and they were stacked on top of each other, so they were vertically stacked, hence the name of VStack. And as you can imagine, you also have an H stack for horizontal stack. And you also have a Z stack to put things on top of each other on the Z axis, so from the bottom to the front, so on this like axis, so like that, where I don't know if it makes sense what I'm doing, but where you're putting like one thing on top of another, but in a direction that faces the screen. I don't know if it's super clear. If you want to know what a Z stack is, look at its documentation. I'm sure that there is like a good example with a good image to explain what it is. But I just wanted to shed some light on what this VStack is right here. So now they're going to show us how to create, how to add a view using the library. So it's a way to add a view using the UI in Xcode. When you have some experience, usually you don't use it, you just write it by hand. But when you're just discovering and learning, I think this can be quite useful. So you do this by clicking the Add button, so the plus at the top of the project window, which opens the library. You can also open the library by choosing View, Show Library, so in the menu, in the menu bar, and you can use the library for quick access to SwiftUI components, colors, and images, as well as other items you'll use frequently when building an app. You can click and drag to position it. To dismiss the library, press escape or click anywhere else on the screen. So like that, we can open the library. And you can see that we have examples of snippets of code. And I think here what we are interested in are SwiftUI views. So it's this panel right here. Make sure you pick this one if this one wasn't selected by default. And so we have several kinds of SwiftUI views. We have buttons, date pickers, color pickers, forms, gauges. So let's see which one we need to pick. I think we need to pick a text. So they tell us to select the first icon just like I did, all right? And then in the search bar, you type text in the field at the top to narrow your search. Then from the list below, you select text to insert it into your code and double click on it or press return. And the new view has a placeholder string in the blue capsule, which is highlighted by default. So let's see what that means. I need to reopen the library because I left Xcode. So text, and I want this one, so I can just hit return, and you can see it has put the new text where I had my cursor. So most of the time when you want to create a view, you will probably most likely type it because you will remember it, but when you're still new to it and you want to have an overview of what's available, this library right here can be quite useful. But to be fully honest with you, I don't really use it on a day-to-day basis because most of the time I already know what I want. But it's a great tool when you are still learning. And so we have this placeholder, and so we're going to replace it with this text message. So actually, you know what? I'm going to do the same thing so that we have the same content. So here it was knock knock, and then the other one is who's there. And so here we have a placeholder, so we can double click on it, and we can replace the content with this who's there string. And you can see it's being displayed in the preview. Okay, now we're going to use code completion to add something called modifiers. So now that we have a pair of chat messages, we are going to use view modifiers to change their appearance and behavior. So we're going to add an empty line below the first text view, so like this, all right? And then we're going to start to type .pad, so PAD, then pause to let Xcode show code completion suggestions. We're going to use the arrow keys to highlight padding with this argument, so edges and length in the menu, then press return to insert the padding modifier into your code. So we start typing. So you can see it's actually the one that's being selected by default. So I can move to select other modifiers which also contain this PAD string. And so I'm going to hit return. And you can see I've added some padding around the text by calling what's called a modifier on the view text. So we'll see, I guess this is going to explain what a padding and what a modifier is just after. Here they show that you can show or hide code completion by pressing escape. So indeed, you can do it like that with escape, both to show it and to hide it. So that can be quite confusing when you are new to Xcode because in other software, it's often like control and space, for instance, to trigger code completion. In Xcode, it's actually escape. And when I started doing iOS development, so more than 10 years ago, it took me a bit of time to understand that it's escape because I just was not used at all to using escape to open something. You're used to using escape to exit something, but not to open it, but actually to open or close code completion in Xcode, you use escape, which kind of makes sense in a way because it's quite easy to hit. The key is quite large on the keyboard, so it makes sense, but it can be surprising when you are not aware of it. It's a good thing that they mentioned it. So now let's talk about this padding modifier. The padding modifier adds extra space around the edges of a view to separate it from its surrounding views, to separate it from a visual point of view. You apply modifiers to views using dot notation, so using this dot right here. That's why there's a period before the word padding, and we say that we call the modifier padding on the text. And basically, by calling the modifier padding on the text, we get a new text, which is a text with padding applied to it. That's a way to understand it. And you can compose modifiers, so you can call one modifier after another. So we're going to add a second modifier to give the chat bubble a background color and a shape. So just below the padding, we start typing dot back, then let Xcode show us code completion suggestions, and we're going to choose background style in and press return to add it to our code. So let's see that. So it's background style in, so it's this one right here. So I'm going to hit enter, all right. And they tell us that there are often multiple versions of the same view or modifier. This version of the background modifier lets you set the style of the background and give it a shape with the argument in shape. So when they say this version, they refer to the doc of the version we've selected. So if I click it, you can see, sorry for the white screen if you were watching this in a dark lit room, sorry for your eyes. So this is the version we've selected. So when you have a function like background with the same name but several possible sets of arguments, it's what we call overloads. So overloads is when you have the same function or method with the same name but a different list of arguments. We say that they are all overloads of background, for instance. So you can have several overloads. Let me show them to you again. So you can see all of these, they are overloads of background because they have the same name, background, but they take different sets of arguments. And because they take different sets of arguments, the compiler is able to tell them apart and to know which is which. Oh no, I've lost where I was. Damn it. So where was I? We were in Hello Swift UI and we were, I think, in... no, this one. This one, yes. Okay, we were adding the background. All right. And so, okay. So next step, the modifier requires arguments between the parentheses to specify the style and shape. Xcode automatically highlights the placeholder for the first argument. We're going to type color.yellow for the first argument, then press tab to move on to the next argument. And you can see other color options by typing color dot and viewing the code completion list. So let's see. So color dot, indeed, we can see several colors. So we're looking for yellow, which is here. But we could have also started to type to narrow down the possibilities. And so color is what's called a type in Swift. And then this type has members, and so you can access them using also the dot notation. So we've provided the first argument. Now it's still not working because we need to provide a value for all arguments, and we still need to provide the shape. What I will do is that I will display the call over several lines. This way it's easier to read. So this is a syntax which is kind of nice, and you can actually get it automatically in Xcode by putting your cursor inside the call and doing Ctrl+M, and it will format it that way. And this way it's easier to read. I personally find. And so what do we do for the second argument? So we're going to begin typing a rounded rectangle for the second argument to the modifier background. And from the code completion list, we'll choose the version of rounded rectangle with an argument labeled corner radius and set the value of the corner radius to 8. So let's do it like that. Rounded rectangle, the one with a corner radius, and the value of 8. All right. And so now the code is working again, and you can see that we do have the padding, so that added some extra space around the text, and then we colored that padding in yellow with the shape of a rounded rectangle with a corner radius of 8 points, like this. So this is our first venture into trying to add some styling logic to our UI components. So before adding modifiers to the next chat bubble, we'll do a quick experiment to see how the order of modifiers affects your views, because this is super important to understand. So reverse the order of background and padding modifiers so that the padding comes after the background. So we're going to move this line from before the background to after it. You can see we don't get the same thing. And you can notice how the chat bubble's appearance changes. So at the bottom leading corner of the preview, click the button to enter selectable mode. So in a live preview, the default mode, you can interact with your interface to test it out. So if there is a button, for instance, we can click on it. in selectable mode, so what we're going to select with this button here, we can click elements in the preview to see more information about them and to highlight the corresponding code in the source editor. So you see now, if I click here, it selects the corresponding code in the editor. And so we're going to click the top message bubble to select it. Xcode shows the selection by drawing a thin blue border around it. So we've selected this part right here. And you can see it corresponds to this piece of code right here, the one that's highlighted. The selection rectangle encompasses the colored bubble and the empty padding around it. And now, if we restore the original modifier order by putting the padding before the background, we can see that the colored bubble now fills the selection rectangle. So I'm going to move this back at the top, and you can see that now the blue fills entirely the rectangle, whereas before it only filled the part that was before we added the padding. So why is that? So we're going to take a look at the sequence of modifiers in our code. So let me make sure that I'm not covering, yes, perfect, I'm not covering it. So let's take a look at the sequence of modifiers in our code. The padding modifier creates a new padded view with empty space around it, which is affected by any modifier coming after it. And what's affected is the white empty space. If you want the padded area to have a background color, you must modify that padded view. So you can see that you have the text. If you put a background color, then you put a background color just on the space occupied by the text, and then the padding adds extra space, but that space comes after the background color yellow modifier, and so that extra space is going to stay white because it was applied after we colored. Whereas if we apply the padding before, then when we color everything, and so we color the space occupied by the padding as well. So another way to see it is that putting your shoes over your socks is different than putting your socks over your shoes. It's kind of the same thing when you think about it. And it's important to be able to have this distinction in the order, because there are situations where you might want to have the behavior on the right, but there are potentially situations where you want to have the behavior on the left. For instance, if you make a button, maybe you don't want it to touch like the very border of the screen. Maybe you want to have some empty space between the border of the button and the border of the screen. So there are times where you will want what's on the left, and there are times where you will want what's on the right. So it's good that the syntax we have in SwiftUI allows us to define both, because this kind of possibility that also makes SwiftUI quite a powerful framework. If we could only do either the one on the left or the one on the right, we would be quite limited quite soon. All right. It's good of them to have explained this. And now we're going to change the preview back to live mode by clicking the button just before the selectable mode. So this one right here, the default one. And I'm going to make the text, the texts a bit more visible. All right. And step 3, we add padding and background to the second chat bubble, this time using a different color. For instance, color teal. So remember, me, I copy paste because I'm lazy and it's not interesting if I spend all of my time writing code, but you should try to write it yourself. And remember to format across several lines. You do Control and M, and the code, I think, looks better that way. So now we have 2 different formattings for each of the text bubble. All right. What's the next step? Okay, so actually we finished this part. So check your understanding. What type of data in Swift represents written language? So if you're watching the replay, now would be a good time to pause and try to understand the question yourself. Don't just wait for me to give the answer. So what type of data in Swift represents written language? Text, writing, or string? So it's not writing because we didn't cover it at all. Is it text or string? So it's actually string because string represents the data. Text represents how to display the data. And remember, this difference between the UI and the model is extremely important. So it's indeed string, that is a Swift type that represents written language. Then, which modifier order expands the background of a view? So we have padding and background, and then background and padding. So what expands the background of a view? So it's kind of hard to understand what they mean. If they mean that the background, so for instance, the blue background will look bigger, in that case, it's the first one, because we apply the background after the padding. So if I understand correctly, which is which modifier order will make the background color apply to the extra space around the view, then it will be the first one. Okay, so I got it correctly. So you apply the background modifier after the padding to include the padded area in the background. So I understand this expand correctly. Last question, true or false? You provide arguments between braces to provide related data. So this is false. You provide arguments using parentheses. Braces are to define scopes of code. And so I was correct. Arguments, they come between parentheses. All right. So let's read the wrap-up about exploring Xcode. So the first chapter. So time to reflect on the concepts we've learned and get ideas for ways to practice using text and modifiers. So what have we learned? What are the concepts that we have learned that we should reflect on? So SwiftUI contains the components used to build the interface of an app. Views and modifiers are the foundation of SwiftUI. You can use them to make the most complex, powerful, and beautiful app you can imagine. So we just covered the very basics, but you can make very complex apps using what we've using this basic building block that we've just covered. So what topics and skills have we covered? Creating a new project in Xcode, the structure of Swift code, including keywords, braces, parentheses, and dot notation. The Xcode library, writing code using code completion, text views and the modifiers that change their appearance, ordering modifiers to achieve a desired layout, and how can you continue practicing? So if you want to extend your app, so usually these are the easy challenges. So you can add more messages to the conversation. You can tinker with the color schemes of your message bubbles and their text, using code completion to explore all the built-in named colors. So maybe a red color, a blue color, a gray color. You can try to make these changes. You can try to add shadows to the bubbles by using the shadow modifier. Or you can try to modify the VStack by adding an argument to change the default spacing between its elements, like this, so passing a spacing of 5 when creating the VStack. And if you want to challenge yourself, so this is something that is usually a bit more complex to do, you can start a new project called Myself in 6 words, use the text views to display 6 words that describe you, give each word some padding and a different background color. For an extra challenge, try displaying the words horizontally and vertically by nesting HTAG views inside VStacks. So I mentioned HTAGs before. This is your sign to try them if you wish to. So that could be a good way to challenge yourself if you want to. If you're watching the replay, also could be a good time to pause, reflect, maybe try a few of these challenges and come back for the next part once you've been able to just like digest a bit these new concepts. So next step, we are going to cover view structures and properties. So as you can see, there is 1, 2, 3, 4, 5 chapters. I won't cover all of them in a single live stream because I would be dead on arrival. So I think I will cover the first 2 today. So we'll still cover this one, then these 2 next week, and probably the last one last time, or maybe it will depend on how long each of them are, but I will cover view structures and properties right now, and then for the next part, it will be next week. I didn't want to open the documentation, so actually, I wanted to move on to the next chapter, so it's this one. Customize views with properties. So we're going to create a SwiftUI app by building custom views to make a multi-day weather forecast. In your custom view, you'll use properties to customize the display for each day. Because in our current view, everything you see was written in the code. All of the data was written in the code. This is what we call having hard-coded data. But of course, if your app was to be like that, you would need to write a view for each possible string that the app displays. So of course, that's not possible. What you want to have is to have arguments that the view can display. And so that's what we're going to focus on right now, if I understand it correctly. So we're going to design custom views using structures. Structures are a way to organize your code so that related pieces of code are packaged together. Every structure has a name that lets you reuse it like a template anywhere in your app. Actually, we've already used structures before because image is a structure, text is a structure, even string is also a structure. With structures, you can write code that is more efficient and has fewer errors because you are building something once and then reusing it in several places. And so you only need to build it successfully once, and then it will be correct in every place that you use it if it was correct in the way you've built it. So we will be creating a new project in Xcode. So now you know how to do it, and we'll call it weather forecast. So let me go in Xcode. Let me minimize this project. Let's create a new one. So I did Command Shift N to create a new project. So it's an app. I call it weather forecast. All right. I just save it. Okay. So let's do that. Put it on my desktop. All right. And so we're going to prototype a forecast view. So we'll create a simple interface. So this one right here, simple, but yet more complex than what we've done before. To display two weather forecasts, notice the repeat pattern in the interface with the name of the day, some kind of icon, the high temperature, the low temperature, obviously in Fahrenheit degrees, because the day we have this in Celsius degree, we are in a very, very bad place. And I think we are likely to be dead the day we have this in Celsius degrees. Even worse if it's in Kelvin degrees. So this is definitely Fahrenheit degrees. You can see the tutorial was written by people in the US, but actually they might. I don't know if we're going to format the degrees using a formatter, but if we do, they might appear as Celsius because my computer is definitely on the European local. So let's get started. Step 1, in content view, delete the code inside the VStack. So let's do that. And that's it. It's gone. And replace it with a simple weather forecast. So remember, I'm copy and pasting, but you should strive to write it by hand. Let's see it appear. Let me make it a little bit bigger. Something like that. All right. Then we add an image view to our forecast and use it to display an SF symbol as a sun. If you don't know what SF symbol is, it's a font of characters that contains icons and that contains basically all of the built-in icons you can use for to add icons to your app. And it's built in into iOS, so you don't need to include anything inside your app. So it's pretty useful. So this kind of image requires one argument, whose argument label is system name, so the label of the argument. And if you want to browse all of the SF symbols available, you can download an app that allows you to do it. So I would recommend that you check it out if you want to see all of the SF symbols which are available, and there are quite a few of them available by now. So I've added the symbol, the icon of a sun, maximum amount of sun, and being filled. But you can see, for instance, if I remove the fill, then it's empty at the center. So you can modify like that, and the app SF Symbols app allows you to figure out how you get this string to display the icon of a sun with a field center. Okay, step 3, we use the foreground style modifier to make the sun icon yellow. So we're going to add the foreground style. So careful, we only apply it to the image like that. All right. You can see it's become yellow in the preview. So you use the foreground style modifier to apply a color to the foreground elements of any view. For example, setting a color as the foreground style of a text view changes the color of the text. And here, for this kind of image, which can be recolored, you can also use foreground style in order to set its foreground style. And in this case, the style happens to be a color. Next step, we get ready to add a second forecast by right-clicking on the VStack and choosing Embed in HStack. So let's see. Actually, I remove the VStack also. So first, I need to put my code inside a VStack. So I do right-click, Embed in VStack. Actually, I need to move the rest inside the VStack, like that. All right. So my bad, I should have kept the VStack. And then I right-click the VStack and I embed it into an HStack, like that. All right. An HStack is a container view that arranges views horizontally, and a VStack arranges the view it contains vertically. So I talked about it a little bit before. There is no change to the interface because the HStack only contains one element, and when it does, it doesn't do anything specific, it just displays that element, but there is nothing else to display, so the HStack is kind of like what we call you can often hear the word no op for no operation. It's something that's there, but that in the current context does nothing. And then we're going to copy the entire VStack, including the padding modifier, and then paste the code below the first forecast to create a second forecast view, and we update the data to display the next day's forecast. So actually, I should have also kept the padding on the VStack, so I've put it back. And so you can see now I need to add the second VStack. So actually, you can do it by copy and pasting the first one and then changing the data. Me, I'm just copy and pasting from the tutorial so that I don't make a mistake. And you can see what's interesting is that in the code, they are happening one after the other. So they are put together vertically in the code, but in the code, every line is going to be vertically after it's the previous line. So don't be confused by that. They are still displayed horizontally because we've put them into an HStack. So I'm saying this because when you are very new to computer science, you might be confused as to like, why are these two things side by side when they are one on top of each other in the code? It's because in the code, the next line is always after the previous line. Like code is only like, it only grows in one dimension. Like you only have lines, you don't have an array with several cells. So it will always be one after the other, but you can still choose how the views should be displayed and composed on the UI. And here we did it by choosing an HStack, which makes our two views being displayed one next to each other horizontally. If I change the HStack into a VStack, then they are displayed on top of each other. All right. Next section will be about creating a custom subview. So instead of continuing to copy and paste your code, which is a bad practice, you might hear the word DRI for don't repeat yourself. Because usually in computer science and computer engineering, if you write the same kind of code more than 2 times, it's a sign that you should put it back into a single place so that when you change it into the future, the change will be applied everywhere. Is the idea that I was getting at and the tutorial was getting at the beginning of this chapter of write something once and use it in several places. We're getting there. So we're going to encapsulate the code to display a day's forecast in its own structure to make a customizable forecast card. So step 1, we're going to right-click the VStack for the first day's forecast. Xcode presents a menu of common actions and we choose Extract Subview. So Xcode will replace the VStack with Extracted View. Look further down in your code to find the new custom view, which will be introduced by struct Extracted View. And a subview is a view inside another view. For example, in the default code for a new project, text and image were subviews of content view. You might also see the word child view, and you can consider child view and subview to be basically synonyms. I think most of them they will be used to describe the same thing. So let's do that. We select the first VStack and we do extract in subview, and you can see it created a new view here at the bottom of the file, which is then used right here. And of course, I could use it a second time if I wanted. But let's see how the tutorial gets to this point. So in both locations, we're going to rename extracted view to day forecast, so a name that makes much more sense in our context. And by the way, one of the hardest things in computer science is how to name things correctly. It's harder than it might look. So we're going to rename it, so like that. So extracted view here and here is renamed to day forecast. And now, as they were pointing out, anywhere you type day forecast, you'll use all the code you extracted into the new view. So the view that's right here. Now that you've created a day forecast view, you can use it for each day forecast. So we're going to replace the second forecast with another day forecast view. So I'm going to remove this and replace it with another day forecast like that. You can see now they have the same data because they are both using this piece of code. But what's nice is that if I make a change here, the change is reflected in the two places. So now this right here has become the single source of truth for these two different pieces of UI in my app. So this is quite powerful, and so this mechanism is what's called also factoring code out. You can see the word factorization. It's one of the reasons why computer languages are so powerful, because you're able to create higher level abstraction that you can then reuse, which make it much easier to write code. I know that when I started to learn computer science, I was like, but how can people write such complex systems without making mistake and updating everything, and it all works like so nicely? And then you understand that there is this idea that you can reuse the same thing in different places, and you can customize the behavior of the thing by passing arguments, which we will see just after. And then it's like, oh, okay, you understand how it works. Because it's very easy to be super naive when you don't know about it. Like the first time I used an iPod Touch, so back in 2007, so quite a long time ago, like 15 years ago, even more, like 17 years ago actually, and I was like, wow, it's amazing, like all of the apps, they have the same buttons and everywhere, like how do they manage to sync together the developers to have the same apps all look the same? The reason is because you can create reusable components, and actually when we use text and image, they are reusable components. So that's the power of computing languages in a nutshell. Without this ability to do so, we wouldn't have the complex system that we have today. So let's examine our code. There are three places where you reference day forecast inside the HTAG. So sorry, these were two separate sentences. So examine your code. There are three places where you reference day forecast. So two places in the HTAG and one in the struct. So inside the HTAG, you're creating two instances of day forecast to display on the screen. And at the bottom, you're defining what a day forecast is and what's its content. The word instance here is very important. You can see here the structure as a template. And then whenever you use the template, you create an instance of the template. And so these two things are instances of day forecast. So they are instances of the same template. They are shaped. There are two things shaped by the same mold, to say it differently. And so you define or declare a structure using the struct keyword, and you use or you create an instance of the structure by typing its name followed by parentheses. So this is super important. It's another way to say what I was mentioning about being able to factor code out and reuse it in several places. So now let's generalize the day with a property. So you can use properties to display any forecast data using your custom view. Start by making the day of the week customizable. So right now it's still all hard-coded. So in the sense that Monday is written, it's written like it's spelled out and it will always display Monday. Let's make this customizable. So we're going to add a new property to the day forecast view to store data about the day of the week. You add a new blank line between the property and the body property below it. So this is a property. So it's something that stores data. Is I guess the most generic way to define it. And so they say we do let day equal string. You see why I try not to type, because I make mistakes very easily when I'm focused on also explaining. All right. So you can use blank lines in Swift to make your code more readable. They have no impact on the way your code runs. Important, Xcode displays an error which you'll fix in a moment. So if you have an error, it's normal, don't be alarmed by it. Before you fix the error, let's take a look at the property you just created. To declare a property, we've just used the let keyword. A property has a name, so by using an identifier, followed by a colon, and then the kind of data it holds. This property's name is day, and it holds a string. In Swift, kinds of data are called types, and that's also the case in most programming languages. You can read the code you added to the day forecast structure like this. Day is a property whose type is string. Or you could say day is a property of type string. I just want to say something. When they say that you use the let keyword to declare a property, actually, let, you declare a constant property, so a property that cannot be changed after the instance has been created, but you could also use var, so var, to declare a property that can be changed after the instance has been created. Both keywords, let and var, allow you to create properties. It's just the mutability of the property that will differ depending on which one you use. So now let's look at the error when you first use the day forecast. It says missing argument for parameter day in call. So click the icon next to the message in Xcode to expand it. So that's what I did right here. So when you add a property to a structure, you need to give it a value every time you create an instance of the structure. So every instance of day forecast needs to be told which day it should store. And when you don't, you get an error at compile time. This error means that you haven't given the day property a value. So we'll click the fix button in the error banner to add the argument label day colon. So like that. And now we still need to provide the actual value for the day. So we will replace the placeholder with a day of the week in quotation marks. And so what we're doing here is calling the initializer for day forecast and passing a string argument for the day parameter. So parameter is the value that the day forecast will use inside, and we pass a value for it for the specific instance. But as you can imagine, we will pass a different value in the second instance of day forecast. And it's this ability to pass different values for the same argument in different places that makes us able to use the same structure in several places to cover several use cases. So here I'm passing mon as the string. Okay. And of course, we need to fix the mistake for the second instance of day forecast. So we'll do it, and this time we will pass Q for Tuesday. All right. But you can see the preview still doesn't reload because there is still a mistake in another file of the project. They say it here. The preview doesn't change because you're still passing a string literal into the first text view in the day forecast structure. So, oh yes. So actually there is not an error, but we don't see Q, so for Tuesday being displayed here, because even though we've passed a value for the argument, that value is stored correctly, but it's not used anywhere. We don't use this anywhere inside the body of the view. So it makes sense that the change is still not reflected on the screen. Actually, it's a great example of this distinction I was mentioning between the UI and the model. Our model is correct, we've passed the correct value. However, we don't use the model in the right way when building the view. Here we don't use the model at all. And so the UI isn't updated. So once again, UI and the UI and the model are different, and you can get one correctly and get the other one wrong, and that happens more often than you would think. So now we use the day property in the text view of the day forecast structure, so the preview reflects the data we added above. So we no longer pass this hard-coded value, but rather we pass the content of the property day. And now you can see the change is being reflected on the screen, and so we've achieved our first example of factoring code out and being able to reuse the factored code out, but with slight differences that we control through the arguments that we pass each time that we create an instance of our struct day forecast. And here we have a note that the day property holds a string value. By using the property as an argument, we can pass its value to the text view because text expects a string, so the types are compatible. Now let's take a look at how the string value journeys from your content view into an instance of day forecast and from there to your interface. So that's great because they're giving like a visual representation of what I've tried to explain just using words. So it will be nice to see this even better explanation. So, okay, I'm hiding the part, but it's not the most important one. The ones that are interesting are highlighted and I'm not hiding them. All right. So you can see that when we create the day forecast, we pass in the value Monday, it's stored inside the property, and then the property is used to display on the screen something. And so, thanks to this journey of the value, if we pass Monday, in the end, mon is displayed on screen. Same thing if we pass Wednesday or if we pass any other value. And we've seen that when we had forgotten to do that part right here, then the data wasn't, the model wasn't displayed on the screen because we were missing this second red arrow right here. So this one is about getting the model correctly, and this one is about using the model correctly, which, remember, are two very different things. You can get one correctly and not the other, or you can get both incorrectly. This can also happen, but of course your goal is to get both correctly. All right, now we're going to use int to display temperatures. So we've displayed strings of characters. Now we're going to display numerical values. So we'll extend day forecast to generalize the temperature range. We'll add properties to represent temperatures as numbers using a new type, int, which stands for integer. Then use a string interpolation to display the temperature into a text view, because the text view doesn't know how to display an integer directly. This integer needs to be formatted into a string. And there are several ways to format an integer. Imagine like 1000. Do you add a separator between the 1 and the 3 zeros? Do you add a dot and then 0 to say there is nothing after the decimal point? There are several ways to decide how to format a numerical value, even one as simple as an integer. So first, we'll store the high and low temperature as int properties in day forecast. Int is a data type that represents a whole number, and more specifically, it represents an integer, whether it's positive or negative. So we'll get errors like we did when we added the day property, because your day forecast initializers are now missing some arguments. So let's add the high and low properties to the struct. So like that, I've added the two properties. Now, of course, we need to update the call sites, so the places where we create the day forecast and provide the temperatures. So I'm going to split the calls across several lines so it's easier to see during the live stream, because we don't have a lot of real estate in the editor. Okay. So you can see, just like before, the values are not reflected because we are still passing hard-coded values here. So we need to use the high and low property inside the body. So let's do that. So in day forecast, we're going to update the text view initializer for the two temperature values. And if we do that, we'll get another error. So let's see. We're attempting to use high and low right here. And we're supposed to get some errors. Yes, they are here. They say no exact match in call to initializer, which can seem quite cryptic when you don't know more about it. So let's try and see what they have to tell us about it. So we get another error, no exact matches in call to initializer, because there's no way to initialize the text view with a numeric value. You need a way to convert a number to a string to pass into a text initializer. You can use a string interpolation to do just that. So what is string interpolation? We're going to change the int values in the text initializers to string literals using interpolation to insert the values of your two temperature properties. If you want to display the value of a number in the text view, which expects a string, you have to change the number into a string, which you do like this. So by using quotation marks and then putting the integer property in between parentheses with a leading backslash. So this seems a bit weird, but once explained, it will all make sense. So like that, and same thing for the other one. What we're saying is basically, this is a string, and then take this integer and turn it into a string. The reason is that in memory, an integer is not stored the same way than a string of characters. And so you need to do this conversion somehow, and this is Swift syntax to do the conversion, which is much nicer than what you would have in older programming languages. And now you can see that we are reflecting the data we've passed. We've lost the contextual information about being the high and low temperature, but I guess we are going to put them back. So indeed, we update our text view initializers to include the high and low labels before the temperature. And so that's why we have this name text interpolation, is because this feature allows us to interpolate other types than strings inside a string. So here we have something that's a string, like here, from... oh, actually, I'm realizing that part of the code might not have been displayed. Oh, I'm sorry about that. I'm going to make sure that... yeah, the Xcode window was going a little bit further down than I thought. Okay, you should be able to see everything now. So this is a string, and then in this string, we are interpolating this value. So we're turning this value, which is a number, into a string and putting it into a string. And then we could also add other stuff after if we wanted. So that's a really convenient way to put more complex data types into a string and to interpolate them within a string. So hence this name of string interpolation, which might seem a bit weird when you don't know where it comes from. What do we do next? Let me check. What do we... I didn't mean to do that. I wanted to go back to the tutorial. All right. That's the one where you can see that I'm starting to get a bit tired, because for me in France, we're getting close to 10 p.m. And so we're getting close to the end of the day. Hopefully we'll also get close to the end of the chapter. And so experiment. Try changing the text in the surrounding, in the text surrounding the interpretation of the temperature. For example, we could type the degree sign if we wanted. So you can use Option O to do it if you use a US keyboard, I guess, because me, I have a French layout on my keyboard, and I can do Shift and the closing parenthesis, and I get, so not here, I get the degree sign. And this is a great example of adding text after the interpolation. Much better one than what I had done of just typing gibberish. So good on them to have suggested this. All right. Then we'll use computer properties for the icon and the color. So we're going to add another property that uses a boolean, a value that is either true or false, to compute what appears in the image view. We show a rain cloud if the value is true and the sun if it's false. So we are in a world where the weather can be either super sunny or super rainy. It's simplified, but it will do the trick. So we add this new boolean property. So remember, boolean means that can be either true or false. So it's like you have only one bit of information. It's either true or false. And I say bit in the sense that it's 0 or 1. So it really takes only a single bit when you want to store this into memory. So like that, let is rainy of type bool for boolean. All right. Then we have our good old errors to address. So we need to pass a value for the argument is rainy when creating the day forecast. I'm gonna put them back on several lines. And you can see the first one is not rainy, but the second one is rainy. Okay. Now, how do we choose the icon that we use depending on whether or not it's rainy? That's what we're going to do next. And here we have a little note that's important, that the order of the parameters in the initializer matches the order of the declarations of their matching property. So you can't add the new argument at the end as you did before, and the order does matter. So that's why they didn't make us add the argument at the end to show us this nice little subtlety. So because the isRainy property is a bool, you need to write code for what to do when the value is true and when it's false. To do this, we're going to create what's called a compute property that represents the icon names. What's a compute property, you might ask? It's a property that doesn't store a value directly, like the store properties we declared earlier right here, using let. Compute properties use the var keyword because their value may vary depending on the result of the computation. So you can think about them as values which are created on demand every time you ask for them. Just one thing that I want to point out, because here they oppose using var to create a compute property and let to create a stored property. That's true. However, it's like when you want to create a compute property, you can only use var because it can change at every call. But when you want to create a stored property, you can use either let or var, depending on whether or not you want it to be mutating. Let will be non-mutating and var mutating. So here, they make it kind of sound like there is like strong opposition between var for compute properties and let for stored properties. It's not the case. It's more subtle than that. You can only use var for compute properties, but you can use either var or let for stored properties depending on whether or not you want them to be mutable. So I wanted to point this out. It's one of the very rare flaws of the tutorial up until now. They've done a really great job. It's the only flaw I've been able to find in the explanation up until now, but they've really done a great job of it. Okay, so let's add this new compute property called icon name, and apparently we're going to get an error. So missing return in accessor expected to return string. All right. So code that computes a value must provide the value using the return keyword. And what's accessor? It's another name for a compute property. It's kind of like its scientific name for the compiler. You know, just like when you have like animals, they have their regular name like cat, dog, and then there is the scientific name in Latin. It's kind of the similar thing. And so we're going to start by saying, okay, the icon name, we will just say it's always cloud.write.field. So it's always going to return this string when you call the property icon name. All right. So if we remove the return keyword, what's going to happen? Actually, it's still going to work. Why is that the case? It's because Swift encourages programmers to remove the return keyword if the code is simple enough. And by simple enough, they mean if it only contains a single expression. You can choose whether to include a keyword to remind yourself of the function of the code or to remove it for conciseness. Here you can see that there is no return in the body, and the body here is also a compute property. So we can leave it or not. I will just leave it for now, but you can remove it if you want. So then we will replace the string literal sun.max.fill in the image initializer with a reference to the new icon name compute property. So let's do that. I don't really like that they use the word reference here because it's more like we are calling the property. I get that they say a reference in the sense that we refer to the property, but a reference has a very specific meaning in Swift. So I don't like the way they use a reference here. And if you ever hear reference types and value types, this is not the meaning that's used here at all. Here they just say that it refers to it, so it uses it. You can see it, it's used in the same way than using the compute property. And so now we have two yellow clouds because, yes, we have replaced the hard-coded sun icon with this property, but it always returns the same value for now. So we still need to return the correct icon name depending on whether it's rainy or not. So let's do that. And so we're going to remove the simple return statement, and instead we're going to add an if-else statement to return the correct icon name based on the value of the isRainy property. So let's add the code, and then we will read the rest of the explanation. First, we can see that now it's working. So we have the correct icon. It might not make sense to have a yellow color for rainy, but I guess we're going to take care of it just after. So what does this code do? If the condition is true, Swift will execute the code in the braces following the if, so this path right here. And if the condition is false, Swift executes the code in the braces following the else keyword, so this code path right here. So like the simple return statement, you can choose to remove the return keywords in the if and else, so you can remove it like that. You can see that it still works correctly. And finally, so as I was saying, as I was foreshadowing, I should say, the color of the icon also depends on the isRainy property, so you can follow the same pattern to create a second compute property for the icon color, use another if-else statement to return the correct color depending on the weather condition, then replace the color yellow value in the foreground style modifier with a reference to icon color. Here, I would prefer we use with a call to icon color than a reference. And once it's done, we will have successfully encapsulated the full expressiveness of a forecast card, so the day forecast view, in a custom view. You can add one or two more cards to see how easy it is to add new ones to the parent view in which we use it. So let's try and do it like that. So something like this. So icon color, okay? And now we can use the icon color instead of the hard-coded color. And you can see now it's blue when it's rainy. So that's perfect. That's pretty good. Sorry, once again, I didn't mean to do that. That's pretty good to be honest. And so now if we want to add a new day forecast, We can do it super easily. So let's add Wednesday. Wednesday, we are back to being not rainy again. And let's change the temperature a bit. I have no idea how Fahrenheit temperatures work. I guess this would be quite 500 degrees is not good, even in Fahrenheit. Okay, I don't think this is realistic, but at least it allowed us to add a new day forecast extremely quickly, thanks to the fact that we have encapsulated the UI logic of a day forecast into this day forecast subview or child view. All right, guess we should be near. We are almost at the end. Last section, I guess, is to, let's see, no, 7 of 8, there are still 2 left, is to style the custom view. So now that you've made a custom subview for a forecast card, you can easily adjust the style, font, and padding of its elements and see the changes in every card. So in the body of your day forecast view, we'll add a line below text day, then begin typing font and pause to let Xcode display code completion suggestions. So I think we need to go, where do we need to go? We need to go, so here, here, and start to type font. All right, then what do I do? So we see indeed, we see this, okay. Choose font underscore font colon from the code completion suggestions and press return to insert it into your code. So the first one, okay. Then type to replace the highlighted placeholder with font.headline. So like that. You can see something changed in the way the text is formatted. Now it seems to be a little bit bigger and a little bit bolder also. So some code completion suggestions like caption and title are semantic values. So they meant the other options we had here. So headline, caption, we also had title, but we chose to go with headline. So what does it mean to be semantic? It means that their name indicates how the fonts should be used in your app. So you're saying this is a headline, and then it will display a headline with the appropriate style, which might be a bit different depending on whether you're on macOS, iOS, watchOS, visionOS, etc. So you can try using different values for the font modifier. So for instance, we can use title, which will be way better. All right. We can use a large title, which is even larger, or we can use caption, which will be much smaller than just using nothing. So you can see this way you can add some formatting, some styling to the text. All right. So, oh yes, 10 p.m. almost. My goal is to finish close to 10 p.m. because after that I can feel on my voice that it's a little bit long. So it seems that the timing is pretty good on that one, but perfect. All right. So then we use the font large title to increase the size of the image. So why can we use font to increase the size of an image? It's not magic. It won't work with any kind of image. It's because here the SF symbol is a font. So it's already a vector image which you can make larger without any problem. That's why we can use things that are more part of a font, even though it's an image, because it's a character font under the hood. Actually, I think they are already explaining it just right here. So they say that because SF symbols are often used in conjunction with text, you can adjust their size using semantic font names. They're designed to work at many different sizes and weights. And they would go even further. It's because SF symbol, I think, is a font, or at least it's available as a font if needed. Maybe it's not always used as a font under the hood by iOS, but it can also be used as a font if you want. And SF symbols work automatically with dynamic type, so they will scale appropriately when people adjust the text size on their device. Let's try to do it. We actually did it at the beginning, and you can see that if I make the text much bigger or much smaller, everything scales together, including the image, which is quite nice when you think about it. Then we're going to use the font weight modifier, so a different one, to change the weights of the high and low temperatures. We can experiment with different weights from the code completion suggestions. So let's see. So here we can do font weight. And then you can see we have, for instance, bold. So it looks similar to to the day of the week. Maybe we can go for something like medium, which is less strong, or semi-bold, which is a bit stronger than medium. So maybe we can go with like a semi-bold, I don't know, maybe with medium. I guess we should go for the same for both. It would make sense, maybe. I don't know. No, actually, they do semi-bold and medium. So we'll do two different ones. You see? You can see it's subtle, but there is a difference. It's easier to see when you go from one to the other, but there is a difference. Might be harder to see with the video compression or if you're on a small screen, but there is definitely a difference. High is a bit bolder than low. Okay. So the font weight modifier changes the weight of a font without affecting its semantic meaning. So the way using body or headline would. So it doesn't change what it means. It's like you make it look like maybe a title, but it's not a title under the hood. And what you pass as the headline, for instance, I think VoiceOver, if you use the feature to read the voice, so for people who have like difficulty in viewing difficulties, I don't know how you say it. I think visually impaired is the correct word in English. They can use VoiceOver to have iOS or read the content of the screen to them. I think it's able to use the headline to know what should be read first and what should be read only after. But I'm not 100% sure on that one, to be honest. And then we're going to use the secondary system color for the low temperature. So that's what you use for less important information. So a way to structure information by giving different style to different information to different pieces of information according to their importance. So we do here foreground style, and it will be secondary. And you can see it becomes a little bit grayer. Usually apps in their UI design system, they will have what's called a primary color, a secondary color. And the idea is that primary color is used to display the main text, and secondary to display text that is less important. It's kind of like also you will have maybe a primary action color for the button, this kind of thing. Similar to how we have different colors here for the code in a way. It's a way to provide some visual clues so that at a glance, the user can understand what is the important information, what is the less important information. It's a way to give a visual structure of the information. And so by default, the secondary color is this kind of light gray that we can see being used right now. And finally, we're going to add a little padding to the icon. So we're going to add a padding of 5. So we can provide a custom value for the padding if we want. So here we say it's 5 points. So that there is a bit of space on the top, on the bottom, also on the left and the right, which is less visible because there is nothing on these sides, but you can see it's been added to all edges. Of course, you can specify only a specific edge or a specific set of edges. If you wanted to apply, for instance, you could apply the padding only to the top and trailing edges if you wanted. It's possible, or only the vertical edges or only the horizontal edges. You have control over this through the different arguments that you can provide in the different overloads of padding. Oh, actually, last section is the quiz. So we are almost done. All right. Let's do the quiz. So what code creates an instance of the following view? So we have a struct person avatar, we have 3 properties, name, image name, and color, and then the body of the view. So like this, person avatar with argument labels, person avatar without argument labels, or person avatar with this weird syntax. Actually, it's the same than here, but the colons and the commas have been switched. So the correct one is, of course, this one. You need to provide argument labels. Actually, what's happening here is that when you create a struct, you get an automatically generated initializer that takes all of the properties in the order they were declared and that adds external names, so argument labels for each of the arguments. If you wanted, you could create your own initializer and ignore the argument label so that you don't have to provide it. It's considered a good practice in Swift to use the argument label because it makes it much more clear what the role of each argument is. So I would really recommend that you keep this built-in behavior, and Still, regardless of your choice, for this code right here, this is the correct way to create an instance of person avatar. So I'm going to submit this answer. And indeed, I was correct about it. So you need to pass arguments for each of the properties. And you also need to provide the property name in the argument label and provide the arguments in the order in which the properties have been declared. Next question. A property can have a value that changes based on other data. So yes, we saw it, and it's what's called a computed property. So a property whose value is computed every time you call it, and it can use other properties, other pieces of data to decide what to return, and that's what we used to have a different icon and a different color depending on whether the forecast was it would be raining or not. So it's indeed true, and you use a compute property to derive a value from another property or other properties or other things, like it could be like the hour of the day, things like that. And last question, how do you insert values into a string? So remember string interpolation. So which is the correct syntax? So you might remember it's the first one, it's backslash and then parentheses in which you put the value that must be interpolated. So it's the first one. And here there is no trick, like they could have all been potentially correct syntaxes. I mean, not this one, I guess, but they could have all been correct syntaxes, just Swift decided that this is the correct syntax. So it's the first one. And it's the backslash parentheses sequence that inserts the value of its content, so what's inside the parentheses, into a string. All right, let's do the recap to finish. So wrap up about views, structures, and properties. And let's drink a little bit more apple juice. Let's reflect on how we used a structure to create a custom view, and we unused properties to pass arguments to the view's initializers to customize each instance. So let's reflect on the concept. Structures represent a fundamental activity in programming, reusing common patterns of code. By creating a custom forecast card structure, actually it was day forecast, not forecast card. I think they iterated on the tutorial and they forgot to change the name everywhere. But that's actually a great example of why you want to have encapsulate code, because this way when you change it into one place, you change it everywhere, which is not the case here because there was no encapsulation. You had two different pages, and when a change was made on the first page, it wasn't reflected on the second page. So actually, it's a mistake, but in a way, it's a greatly timed mistake. So by creating a custom day forecast structure, we group the view's code and related data, saving ourselves time and reducing the potential for error. Here, we group the view's code and related data. The fact that we stored inside a single unit data and logic to operate on the data is also very, very important and a big part about what it means to factor code out. Usually, you want to factor together data and the logic that operates on the data. You want to put it together into a tightly knit concept, which is here a structure. Structures are general purpose tools for organizing any type of code. As a developer, you'll need to store, display, send, and receive data in your apps. You'll use structures to create models for this data. And you can see that they use the word model here for the first time, I think, but I've used it several times during the live stream, so you might have heard it before if you paid attention to what I was saying, I guess. So I hope that you've heard it before, you've remembered it, but it's nice to see Apple also using this terminology, which is like the way that people refer to data that reflects the state of an app. So which topic and skills were covered? Using a structure to make a custom view, creating instances using a structure's initializer, customizing each instance of a structure using properties, the string, int, and bool data types, which are the most basic types you can use to represent data, and compute properties, which change data based on a condition, or rather, which might return different data based on the current state, because a compute property might also return the same data. It doesn't need to change every time, you know, it's like it computes and returns a value on demand, but this could be always different, this could be always the same, this could depend on the condition. There is no fixed rule for what you do inside of a compute property. And so what can you do if you want to keep practicing? First, you can expand the app we've written. So you can experiment with the style of the forecast cards by modifying the spacing, the font, and the colors, like we did a bit. You can add more days to the forecast, like I did at the end. If you run out of horizontal space, wrap everything in a VStack and group the cards in multiple HTAG containers inside, or look into scroll view to be able to scroll content, which is a great way to go further. You can also create a new custom week forecast view that displays the date range and the summary for the week. So the average low, average high, and number of days of sun and rain. So basically gaining one level of abstraction because we put the content for a day together, then do the same thing for a week. And as you can imagine, the week will be composed of days. So that can be a great way to go further. And if you want to change yourself, you can practice using commit properties. For instance, adding a commit property by adding a commit property to return different colors if the high temperature is above 80 degrees, so high greater than 80. You can use the foreground style modifier to change the text color depending on the value of the property. For instance, put it in red if it's above 80 degrees, which I guess is, I don't know, maybe the equivalent of 30 or 40 Celsius degrees in Fahrenheit. And you can practice creating custom views. So you can also go back to the project we did in the previous chapter, so the chat prototype project, and create a new view named chat bubble and use properties to represent the bubble's text and color, and use your custom view in the content view. So by reusing the text bubble several times, just like we did with the day forecast. So I think that concludes this first video of the series. So next time we'll cover layout and style in more detail, and I guess also button and state, and probably the week after list and fields. So it's been 2 hours, just like I wanted. Perfect timing. I just have to say, so thank you for watching. Thank you to the people who watched live and who asked great questions and made great remarks, because every time they brought some points that I wouldn't have thought myself of bringing. So a big thank you to them. And finally, if you are indeed getting started with iOS and you've watched this video up until right now, which is the end, don't hesitate to tell me in the comments what is your honest feedback. What did you like? What did you not like? What would you have liked me to explain a bit more, maybe? All of the things that can help me better understand what I can improve and create better content, better other and better beginner content. And if this content has been helpful to you, don't hesitate to also share it with other people you might know that might want to get started with iOS, because if it's been helpful to you, there is no reason that it won't be helpful to someone else. I think I've said everything I wanted for the outro. So I just have to say thanks again for watching, and see you next week or in the next video if you're watching the replay for the next part of this series of video about how to get started developing iOS apps with Swift and Xcode. Thank you for watching. Bye-bye. See you next time.